Welcome to Barishal Cadet College and good morning to you all. Hope you all are fine at your home. Dear cadets, you have to follow the preventive tips for your safety. Firstly, wash hands with water and soap or sanitizer at least 20 seconds. Avoid contact with sick people. Don't touch eyes, nose or mouth with unwashed hands. Don't eat raw food, thoroughly cook meat and eggs. Avoid contact with animals and animal product. Due to corona pandemic, our regular classes are not taking place. So now I am here to take your class virtually. I am Abu Said, lecturer, Department of Mathematics, Barishal Cadet College. In this class, I am going to discuss continuity of a function and first principle from chapter 9C of your book, Learning Outcome. After the class, the cadets will be able to explain the continuity of function, determine derivative of exponential function, logarithm functions, determine derivatives of trigonometric functions. Now, continuity of a function. The function f of x is continuous at x equal to a if limit x tends to a, f of x exists. If it is finite and it is equal to f of a. In the other word, f of x is continuous at x equal to a. Limit x tends to a to the power plus f of x is equal to limit x tends to a to the power minus f of x is equal to f of a. That means the right hand limit and left hand limit and the value of a function is equal, then we call this function is continuity function. Again, I repeat, if right hand limit and left hand limit and the value of a function is equal, then we call this function is continuity of a function. Now, let us try to solve a problem. X equal to 0 and for the value of x equal to 1 to describe about continuity of the function f r tends to r, where f of x is defined as x square plus 1 when x less than 0, x when 0 less than equal to x less than equal to 1 by x when x greater than 1. The function is defined here. Now let us try to solve this function is continuous or discontinuous at x equal to 0 and x equal to 1. Firstly, we consider x equal to 0. So let us try to solve. Solution. Let limit x tends to 0 plus. That means the value of a function x greater than 0. You see here 0 x greater than 0 here. That means f of x is equal to x. Now putting the value here. Limit x tends to a to 0 to the 0 plus f of x is equal to limit x tends to 0 plus f of x is equal to x. Again I repeat, 0 plus means x greater than equal to 0. That means the function f of x is equal to x. That's why we're putting the value here f of x is equal to x. Now x putting the value x equal to 0, then we can write 0. In the same way, limit x tends to 0 minus. 0 minus, that means the value of a function x less than 0. X less than 0 here, when x less than 0, then the function f of x is equal to x square plus 1. Now here putting f of x is equal to x square plus 1, because x tends to 0 minus. That's why we're putting x square plus 1. Now putting the value 0 here, then f of x is limit x tends to a to the power x tends to 0 minus f of x is equal to 1. Now putting the value x equal to 0, you see x equal to 0, that means x equal to 0 here, x 0 less than equal to x, that means the value of 0 and x are equal here. That's why we put the value f of 0 is equal to x equal to 0. That means f of 0 is equal to 0. Now since f of 0 is equal to limit x tends to 0 to plus f of x, is not limit x tends to 0 minus f of x, because the value of f of x is equal to 0 and value of x here, the right hand limit is equal to 0 and left hand limit is equal to 1. These three parts are not equal. That's why this function is not continuous at that point. Now let us try to solve another point, x equal to 1. In the same way, limit x tends to 1 plus. 1 plus. 1 plus means the value of a function x greater than 1. Here x greater than 1. X greater than 1 here. That's why we can write f of x equal to 1 by x. Here f of x is equal to 1 by x. Now putting the value 1 here, then we can write 1 by 1 is equal to 1. Now left hand limit. Left hand limit f of x 1 minus, that means the value of x less than 1, x less than equal to 1 here. That's why we can write f of x equal to x here. That's why we can write f of x is equal to x here, then 1, putting the value of x here, then we can write 1. Again I repeat, x tends to 1 plus, that means the value of a function x greater than equal to 1. X greater than equal to 1, the function defined as f of x is equal to 1 by x. That's why we put in the value f of x is equal to 1 by x, and x tends to 1 to the power minus. That means the value of x is x less than equal to 1. X less than equal to 1 here. That's why we're putting the value f of x equal to x here. Now putting the value 1, then we put in the value f of 1. F of 1 means the function 1, fx and 1 are equal. That's why we're putting the value at 1. So f of 1 is equal to 1. Here right hand limit, left hand limit, and the value of a function are same. All the three values are same. That's why we can write this function is continuous at the point x equal to 1. Since limit right hand limit is equal to left hand limit is equal to f of 1, that's why this function is continuous for the value x equal to 1. And this function is not continuous of the value x equal to 0, because the right hand limit and left hand limit and the value of a function are not same. In the same way, we solve this type of problem. Now another question. General definition of derivative. This is most important of differential calculus. This is the main formula for differential calculus. You remember this. General definition of derivative. Let y equal to f of x be a function and del x be a small increment of x and del y be the corresponding increment of y. Here we consider a function y equal to f of x. Now let del x and del y are the small increment of x and y. That's why we can write y plus del y is equal to f of x plus del x. This is number 2. Now 2 minus 1. That's why we can write here y minus y is cancelled. That's why you can write del y is equal to f of x plus del x minus f of x. Now divide del x in both sides. Then we can write del y by del x is equal to f of x plus del x minus f of x by del x. Now taking limit del x tends to 0 on both sides. That means here limit del x tends to 0 and here limit del x tends to 0. Then we get limit del x tends to 0 del y by del x is equal to limit del x tends to 0 f of x plus del x minus f of x by del x. Now limit del x tends to 0 del y by del x is denoted by dy by dx. Therefore, dy by dx is equal to limit del x tends to 0 f of x plus del x minus f of x by del x. This is number 3, is called the derivative of y equal to f of x with respect to x. This is our main formula of derivative with from first principle. The derivative of y equal to f of x with respect to x is also denoted by f dash x. That means or y prime or y1 or dy. That means dy by dx and f prime x or y prime or y1 or dy. All these terms are equal. Generally we use this term or this or this. Sometimes we use y1 or you remember these three terms. When we use y prime, that means dy by dx. Another we use y1, it's also dy by dx. Now writing del x is equal to x in 3, we get dy by dx is equal to f prime x is equal to limit h tends to 0 x plus h minus f of x by h. Therefore, f dash a is equal to limit h tends to 0 f of a plus h minus f of a by h. That is f prime a is equal to limit h tends to 0 f of a plus h minus f of a by h is the derivative of the function y equal to x at x equal to a. Note that dy by dx is a symbol. Here dy by dx is a symbol which stands for limit del x tends to 0. Del y by del x. Dy by dx can never be considered as a function where dy is a numerator and dx is a denominator. But if dy by dx is equal to a, then we can write dy is equal to a dx. Remember these things. Again, I repeat, dy by dx is a symbol which stands for limit del x tends to 0 del y by del x. Dy by dx can never be considered as a fraction where dy is a numerator and dx is a denominator. But if dy by dx equal to a, then we can write dy is equal to a dx. Now let us try to solve a question. Find the derivative of e to the power x from first principle with respect to x. Let f of x is equal to e to the power x. Therefore, f of x plus h is equal to e to the power x plus h. By the definition of derivative, we know d by dx f of x is equal to limit h tends to 0 f of x plus h minus f of x by h. This part are same for all the question when you solve first principle from first principle. Firstly, let f of x equal to e to the power x, f of x is equal to this function, then putting x equal to x plus h, then by the definition of derivatives, we know this. This part are same all the questions when you solve from first principle. Now putting the value of f of x plus h and f of x here, then we can write limit f of x is equal to e to the power x, and limit s tends to 0. F of x plus s means e to the power x plus s, and f of x means e to the power x. Now from logarithm, exponential and logarithm, you know e to the power x plus s is equal to, we can write e to the power x dot e to the power s minus e to the power x. Now e to the power x common, then we can write e to the power s minus 1. Now this is a series of e to the power x equal to, we can write 1 plus x square by factorial 1 plus x square by factorial 2 plus x cube by factorial 3 dot dot dot. Now putting this series here, then we can write e to the power x limit s tends to 0 1 by s, and e to the power s is equal to, we can write 1 plus s square by factorial 2 plus s cube by factorial 3 plus dot 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 and minus 1. Now 1 and 1 cancel, then the remaining part e to the power x limit s tends to 0 1 by s plus s square by factorial 2 plus s cube by factorial 3 plus dot dot dot. Now is common all the term, then a's and a's are cancelled, then the remaining part 1 plus a's by factorial 2 plus h square by factorial 3 plus term containing higher power of a's. Now putting the value of a's here, then we can write e to the power x into 1 plus 0 plus dot dot dot. Here e to the power x into 1 means e to the power x. So d by dx e to the power x is equal to, we can write e to the power x. D by dx e to the power x is equal to e to the power x. This formula we use later on when we solve general derivatives or normal question. Directly we use e to the power x is equal to d by dx e to the power x is equal to e to the power x. Now another question. Determine the derivative of sine x from the first principle with respect to x. Now same, let f of x is equal to sine x. Now putting x equal to x plus h, and putting x equal to x plus h, then we can write sine x plus h. Now we know the definition of derivative is equal to d by dx f of x is equal to limit h tends to 0 f of x plus h minus f of x by h. Now putting the value of f of x and f of x plus h here, then we can write d by dx sine x, because f of x is equal to sine x, and f of x plus h is equal to sine x plus h. Now here sine c minus sine d. You know sine c minus sine d from trigonometry, you know the formula. Sine c minus sine d is equal to, we can write 2 sine c plus 2 cos c plus d by 2 sine c minus d by 2. Applying this formula here, sine c minus sine d is equal to, we can write 2 cos c plus d. C means x plus s and d means x. So we can write 2 cos x plus h minus plus x by 2 sine c minus d. Here c means x plus s. X plus s minus d means x by 2. Now x cancel and x plus x is equal to 2x. Then we can write limit s tends to 0, 2 cos x plus x, that means 2x, 2 cancel, that's why we can write x plus h by 2, and here x and x cancel, that's why we can write sine h by 2 by h. Now separately this term, then we can write limit h tends to 0 cos x plus h by 2 into limit h by 2 tends to 0 sine h by 2 by h by 2. From limit, you know limit theta tends to 0, sine theta by theta is equal to 1. Here theta means h by 2 and h by 2 are same. That's why we can write limit h tends to 0, sine h by 2 by h by 2 is equal to 1. Now putting the value a is equal to 0 here, then we can write cos x plus 0 into cos x plus 0 into 1. That means cos x. So d by dx sin x is equal to cos x. This is our required formula. We use the formula when we solve questions of differentiation. Now another question. Determine the derivative of 10x from first principle with respect to x. Now the same way, let f of x is equal to 10x and f of x plus h is equal to 10x plus h. Definition from derivative, we can write d by dx f of x is equal to limit h tends to 0 f of x plus h minus f of x by h. Now putting the value of f of x and f of x plus h here, then we can write d by dx 10x is equal to limit h tends to 0 10x plus h minus 10x by h. Now we know 10x is equal to sin x by cos x. That's why we can write sin x plus h by cos x plus h minus sin x by cos x. Now LCM cos x plus h cos x. Then we can write sin x plus h cos x minus cos x plus h sin x. We know from trigonometry this formula sin a minus b is equal to sin a cos b minus cos a sin b. Applying this formula here, then we can write sin a means x plus h and b means x. That's why we can write limit h tends to 0 1 by h sin x plus h minus x, because this sin a minus b is equal to sin a cos b. That means sin a cos b minus cos a sin b. That's why we can write sin x plus h minus x by cos x plus h. Now limit h tends to 0 1 by h sin x plus h minus x by cos x plus h. Now separate both this term, then we can write limit h tends to 0 sin h by h, limit h tends to 0 1 by cos x plus h. We know from limit theta tends to 0, sin theta by theta is equal to 1. That's why we can write here theta means h. That's why we can write limit h tends to 0 sin h by h is equal to 1. And putting h tends to 0 here, that we can write 1 into 1 by cos x into cos x plus 0. That means 1 by cos square. We know 1 by cos theta is equal to sec theta. That's why we can write 1 by cos square is equal to sec square x. So d by dx 10x is equal to sec square x. This is our required formula. Now another question. Determine the derivative of ln x from the first principle with respect to x. Here let f of x is equal to ln x, then putting x equal to x plus h. Now from the definition of derivative, we can write d by dx f of x is equal to limit h tends to 0 f of x plus h by h minus f of x. Or d by dx ln x, because f of x is equal to ln x and f of x plus h is equal to ln x plus h minus ln x. Now from logarithm we can write ln x plus h minus ln x is equal to ln x plus h by x. Now 1 by h ln x cancel, that means 1 plus h by x. We know the formula, this series ln 1 plus x is equal to x minus half of x square plus 1 by 3 x cube dot dot dot. Applying this formula here, then we can write limit h tends to 0 1 by h. Here x means h by x. That's why you can write h by x minus half of x square. That means x square by x square plus 1 by 3 x cube by x cube minus dot dot. Now is common, then we can write 1 by x minus half of h by x square plus term containing higher order of h. Then putting the value of h equal to 0, then we can write 1 by x minus 0 plus 0. In the same way, 1 by x. So d by dx ln x is equal to 1 by x. This is our required formula. We use this formula when we solve differentiate related problems. Now determine the derivative of sec to x from first principle with respect to x. Now in the same way, let f of x is equal to sec to x, then putting x is equal to x plus h. That's why we can write f of x plus h is equal to sec 2 into x plus h. That means sec 2x plus 2h. From the definition of first principle, we have d by dx f of x is equal to limit h tends to 0 f of x plus h minus f of x by h. Now putting this value here, then we can write d by dx sec 2x is equal to limit h tends to 0 f of x plus h. That means sec 2x plus 2h, and f of x means sec 2x by h. Now limit h tends to 0 1 by h is equal to, we know sec x is equal to 1 by cos x. That's why we can write 1 by cos 2x minus 2h by 1 by cos 2x. Now LCM cos 2x plus 2h. Then we can write cos 2x minus cos 2x plus 2h. Then limit h tends to 0 1 by h. We know the formula cos c minus cos d is equal to 2 sine c plus d by 2 sine d minus c by 2. Applying this formula here, cos c minus cos d is equal to 2 sine c plus d by 2 sine d minus c by 2. Here c means 2x and d means 2x plus 2h. Now we can write 2 limit h tends to 0 sine 2x plus h by cos 2x plus 2h. Cos 2x limit h tends to 0 sine h by h. From limit, we know limit x theta tends to 0 sine theta by theta is equal to 1. Here theta means h. That's why you can write this part is equal to 1, and putting the value h is equal to 0 here. Then we can write sine 2x by cos 2x plus 0 by cos 2x. Then 2 sine 2x by cos 2x cos 2x. That means we know sine x by cos x is equal to 10x, and 1 by cos x is equal to sec x. That's why we can write 2 tan 2x sec 2x. In the same way, we can solve any type of trigonometric ratio related problem. Then the general formula of derivatives. We use this formula when we solve different type of differentiate related problem. D by dx x to the power n is equal to n x to the power n minus 1, and d by dx cos x is equal to minus sin x. D by dx sin x is equal to cos x. D by dx tan x is equal to sec square x. From first principle, we know this formula. D by dx cot x is equal to cosec square x. D by dx sec x is equal to sec x tan x. D by dx cosec x is equal to minus cosec x cot x. And d by dx ln x is equal to 1 by x. D by dx e to the power x is equal to e to the power x. D by dx e to the power x is equal to e to the power x ln a. Remember this formula carefully, because we use this formula every time. Now this is your homework. Determine the derivative of sine 2x from first principle with respect to x. Determine the derivative of ln 2x from first principle with respect to x. Determine the derivative of e to the power mx from first principle with respect to x. That's all for today. If you have any query, you can ask that in the comment section. Lastly, I would like to remind you the most important thing in this critical situation: you must stay home. and keep yourself safe. Stay fine. Thank you.